In the realm of plastic manufacturing, injection molding and rotational molding stand out as two prominent techniques, each boasting distinct features and applications. Injection molding is a material reduction manufacturing technique. After heating thermoplastic or thermosetting plastic to a molten state, it is injected into a pre-designed mold cavity under high pressure, and the plastic is cooled and solidified in the mold, and the mold is opened to remove the molded product. The molding process mainly relies on the mold cavity to give the product shape. In rotational molding, a measured quantity of plastic powder is placed into a hollow mold. The mold is then slowly rotated in an oven around two perpendicular axes simultaneously. As the mold rotates, the plastic powder tumbles around the inner surface of the mold. The heat from the oven melts the plastic, which gradually coats the inner walls of the mold. Once the plastic has fully melted and uniformly covered the mold is cooled, usually by air or water, causing the plastic to solidify into the desired product shape. Different mold costs. Injection molds are typically made of steel or aluminum and are highly complex in design. Taking the manufacture of an electronic product shell mold with a fine internal structure as an example, its cavity should not only accurately reflect each and every subtle curvature and texture of the surface of the shell, but also ensure that the dimensions of the internal structure are accurate to ensure that the various components can be perfectly installed therein, the core portion of the same need for extremely high precision in order to shape a variety of snaps, grooves, and other structures inside the shell. In order to achieve such a high level of precision, the machining process utilizes a variety of advanced technologies and equipment and high-quality materials, making injection molds relatively expensive to manufacture. However, their high durability makes the cost per unit more reasonable for mass production. Compared to injection molding, rotational molding molds are usually less complex and can be made of cast aluminum, fiberglass, or even some types of plastic. The manufacturing process of rotomolding mold for precision machining requirements are low, and most of the equipment used in its manufacture is ordinary machining equipment, and the cost is relatively low. In the choice of materials, also do not need to use those expensive special steel. General materials can meet the requirements. Therefore, compared with the injection mold, the manufacturing cost of rotomolding mold is significantly lower. This makes rotational molding an attractive option for small production runs or for products that focus on the cost effectiveness of the mold. Different product characteristics. Products made by injection molding often have high dimensional accuracy and smooth surface finishes. They can achieve very tight tolerances, making them suitable for applications where precision is crucial, such as in the production of electronic components, automotive parts, and small consumer goods. Injection. Molded products can also have thin walls, which is beneficial for reducing material usage and product weight. Rotational molded products tend to have a more uniform wall thickness throughout the part. This is because the plastic is evenly distributed during the rotation process. However, the surface finish may not be as smooth as that of injection molded products. Rotational molding is well suited for producing large hollow products with a relatively simple shape, such as tanks, bins, and playground equipment. These products can have a high impact resistance due to the way the plastic is formed during the rotational process. Productivity is not the same. Injection molding is a high-speed process. Once the mold is set up, the injection and cooling cycles can be completed very quickly, allowing for a high production rate. This makes it ideal for mass production scenarios where large quantities of products need to be manufactured in a short period. However, the initial setup time for injection molding can be relatively long, especially when changing molds or product designs. Rotational molding is a slower process compared to injection molding. The heating and cooling cycles in rotational molding take longer, which results in a lower production rate. The heating and cooling cycles in rotational molding take longer, which results in a lower production rate. Additionally, the rotation of the mold requires more time to ensure the plastic is evenly distributed. However, rotational molding has the advantage of being more flexible in terms of product design changes. Since the molds are less complex, modifications can be made more easily and at a lower cost. Different application scenarios. Given its high precision capabilities and high speed production, injection molding is widely used in industries such as automotive, electronics, medical devices, and consumer goods. Rotational molding is commonly applied in the production of large-scale hollow plastic products. These include items like water tanks, chemical storage containers, kayaks, and children's toys. Its ability to create products with uniform wall thickness and good impact resistance makes it the preferred choice for these applications.